Hi dear students, welcome to our online class. I am Jinto Joseph, Ravila Kiyare Vijayashram. Today we are doing 10th standard practical, physics practical number 1, determination of unknown weight by using principle of moment. So at the beginning itself, why I opted this practical work? Because physics is a practical science. Physics is a practical science. Practical works helps students easily and effectively learn the concepts and fundamentals, theories easily. It helps a lot. Without practical, physics knowledge won't be fulfilled. So because of that reason only, I opted at the beginning itself unit number 1. Based on that one practical. So principle of moment, right? Principle of moment. Before doing this experiment, just to learn, already you have studied principle of moment and all. Then once again, I am telling what is the concept behind principle of moment. So before that one, let me introduce some persons. I am Jindo Joseph. This is knife edge. This is slotted weight, meter scale, and some thread. So this is my unknown weight, right? So first of all, I am telling about that principle of moment. What is principle of moment? So consider I am keeping this meter scale on this wedge and attaching some mass over here. So if I am leaving my hand, in which direction the scale is rotating? Scale is rotating in which direction? I am talking about you. For you, the scale is rotating in which direction? Clockwise. So it is clockwise moment. That means this force produces a clockwise rotation. A force can rotate an object. A force can rotate an object. This rotating effect of this force, we are calling it as moment of force. What I am saying, a force can rotate the object. So the rotating effect of this force, we are calling it as moment of force. So what is the equation? You know the equation of that moment of force. Moment of force, M is equal to force into what force we are adding over here. Force into distance. Which distance you will measure? This much of length we are having. So you can measure this distance. You can measure entire distance 1 meter. You can measure this distance. Which is correct? So see, from the point of this point is what? A point of rotation. This is called a point of rotation. From this point of rotation to the mass point, force point. So this is your distance. Force into distance, moment equation. So which moment it is producing? Now for you it is clockwise moment. If I am attaching this mass over this side, what will happen? Say this mass is now on this side. This body starts to rotate in which direction? Which direction? For you, anti-clockwise direction, right? For you, it is anti-clockwise direction. This scale starts to rotate anti-clockwise direction. Why? Because this force produces a moment, rotating effect. Moment means rotating effect. This force produces a rotating effect in which direction? Anti-clockwise direction. So this moment we can call it as anti-clockwise moment. First time it was clockwise moment. Now it is anti-clockwise moment. Say if I am adding one more mass over here. I am adding one more mass over here. I am adding one more mass over here. Say now over here one mass. Yes, fine. So what will happen? Again, if I am leaving my hand, it is moving in which direction? Anti-clockwise direction. Why? Because anti-clockwise moment is greater than clockwise moment. By adjusting the length, see, now I am adjusting the length, leaving, again it is coming to this side, I am adjusting this length again. This mass is too high, yes, see, if I am leaving, before it was rotating in which direction? Anti-clockwise direction. If I am leaving my hand, it is moving in which direction now? Clockwise direction, So this moment depends on distance, because moment equation force into distance. So at one point, imagine, say this clockwise moment, at one point I am adjusting the length in such a way that at one point both becomes equal. this clockwise and anti-clockwise moment becomes equal. At this point, body remains at a stationary, see, it will be in stationary position. So this time clockwise moment is equal to anti-clockwise moment. So what is simply we can say, principle of moment says that if an object is in rotational equilibrium means it is not rotating. If an object is said to be in rotational equilibrium, then clockwise moment is equal to anti-clockwise moment. Clockwise moment is equal to anti-clockwise moment. By using so one equation, what is equation? That means moment of this mass is equal to moment of this mass. Say this is F1 and this is D1. This is F2 and this is D2. We can write F1 D1 equal to F2 D2. F1 D1 equal to F2 D2. So that is about moment, principle of moment. For a body said to be in rotational equilibrium, clockwise moment is equal to anti-clockwise moment. In other words, we can say sum of the moment produced by all individual forces is equal to 0 if the body is in rotational equilibrium. Other words, theory part you study later. Now this is the concept. Clockwise moment is equal to anti-clockwise moment. F1 D1 is equal to F2 D2. Now we are starting our experiment. Say before doing this experiment, first thing I am removing this mass and all. So the aim of the experiment is you need to measure the weight of this unknown object. This is you need to find a wooden piece. I don't know the mass. You need to find the mass of this wooden or weight of this wooden piece. So that is the aim of this experiment. For doing this experiment, you must know the instruments, equipments. We have meters, scale, wedge, knife edge, thread, and mass hanger. Say why we are calling it as mass hanger. Say this is a fixed mass hanger. This is our mass hanger. Total its mass is given 50 gram. Altogether this mass is given 50 gram, and each mass it is written over here 50 gram. That means if you are adding this mass over here, it is 100 gram. If you are adding this mass over here, 150 gram. Alright. So first we are starting with the 50 gram. In many videos or many teachers can teach the same topic in different way. How I am teaching is I am changing the mass. Without changing mass also you can do nothing wrong. All are the same. What I am doing, I am having 3 masses over here, so that I am changing that masses here. Right? Before starting with this experiment, I kept 2 thread over here. The first thing, I need to balance this one over this wedge. So this is a meter scale. Total is 100 centimeter, 1 meter. So where will be the center of gravity? I need to balance this scale over center of gravity. Where will be the center of gravity? If it is a 100 meter scale, definitely it should be 50. But in this case, it is not 50 because this scale is not exact one. Some on this side, some knife dead dent is there. So because of that one, it won't balance at 50. So somewhere nearby 50, it can be 51 or 49, something like that. So first step is balance this scale at a knife edge. Balance the scale. First thing. So after that is again don't go. Yes. Once it gets balanced, you just note down this pointer. Say I am reading this number as 51.8. 51 point over on top end I am reading the scale. 51 at 51.8 it is balancing. Okay, 51.8 it is balancing 51.8. Take some time. So yes, balanced. So you note down this point. If you have a pencil you use just a point, mark over here. 51.7, that is better. 51.7. Fine. Now what I am doing, I want to find the unknown weight. This is my unknown weight. adding this unknown weight. Okay. So here I am not going to change the distance of this unknown weight from the point, from this point of rotation. This one I am going to keep it as a constant. So for easiness, this is 51.7. So here I am keeping at a 21.7. I am keeping this one at a 21.7. Right? So what will be the distance from the point of rotation? This is 51.7. 21.7, so the distance will be 51.7 minus 21.7, 30. Yes, 51, 21, 51 minus 21, 30, 0.7, colors. So this distance is 30. I am keeping this distance as fixed one. Don't change this distance. So in which side it will rotate? Clockwise direction, clockwise rotation. Now I am taking my 50 gram mass, attaching over this end 50 gram mass. 50 gram mass. So when I am looking, this is going that direction. By changing this distance slowly change the distance in such a way that at one point the entire system will be balanced. Yes, somewhere here. Come. Yes. It is balanced over here, right? Okay, this is my balanced point. So take that point. Now you need to measure. Now you can see your tabular column. In the tabular column, in the first side, it is given serial number. Second column, it is given weight in the weight hanger, W2. Weight in the weight hanger, that is our non-weight weight hanger, W2. It is given in kilogram. Distance of non-weight, distance of unknown weight, W2 into D2. Last column, unknown weight is equal to one equation is given. Fine. So now I am now it is balanced with 50 gram mass on this side, and this side unknown weight. This is balanced position. Rotational equilibrium. It is not rotating. Clockwise moment is equal to anti-clockwise moment. Now we are going to the tabulation. So before the tabulation we are going, first you can see serial number. This is my first reading, so I am writing serial number 1. Weight in the weight hanger. See, you can see weight in the weight hanger. This is your weight hanger. What is the weight? So now I am adding 50 gram. So I am writing 50. So it is given, it should be in kilogram. So what I am doing, how to convert kilogram, 50 gram to kilogram, into 10 to the power minus 3 or divided by 1000. 50 into 10 to the power minus 3. This one we can write it as 0.05 kilogram. Right? So that is a weight in weight hanger. Next one, distance of non-weight. You can see this is your non-weight. Distance of non-weight means from the point of rotation to this distance. Point of rotation already we fixed 51.7. This one now it is coming 87.8. So what is the distance? 87.8 minus 51.7. Answer 36.1. So this distance, don't make mistake, because students are while doing this experiment in that final board exam, they are doing the mistake. They don't know how to measure the distance. So distance means from this point of rotation to this point, this one. So 87.6 minus 81.7 minus 51.7, which is equal to 36.1. So that distance I am writing over here, 36.1. Next column you can see distance of unknown weight. D2. This is my unknown weight. This is distance. So this distance already we fixed 51.7, 21.7. So distance is 30 centimeter. That is a fixed quantity. So I am writing 30 centimeter. This is centimeter. You need here what? Meter. How to convert centimeter to meter? Either into 10 to the power minus 2 or divide by 100, which is equal to 0.361. Here 0.3. by this is centimeter, this is centimeter, this is meter, 0.361 meter, 0.361 meter. No need to mention because already you mentioned over here. Next column you can see you need to do W2 into D1. What is W2? This is your W2. What is D1? D1 is 0.361. So I am multiplying this one 0.05 into D1. What is D1? 0.361. So answer you are getting 0.01 0.01805 kilogram meter is the first moment. So to find unknown weight, you can use this equation. What is the equation? Unknown weight W1 equal to W2 into D2. What is W2 into D2? From where you will get W2 into D2? Say this is W2 into D2. What is the value? 0.01805 divided by D2. Which is D2? This is D2. D2 0.3, 0.3, which is equal to, when you are dividing this one, you will get the answer as 0.060. 0.060. That is the first calculation. Now we are continuing this experiment. We are come back to the experiment. Now for repetition, physics, the repeating experiment is must for getting the accurate reading. In order to avoid all anomalies, you need to repeat the experiment. That is one of the fundamental in physics. Always that we don't know whether it is correct reading or not. So we will repeat this experiment. For that one, add your next mass over on this mass hanger. So now it is what? Going this side. Again adjust. Slowly you adjust. At one point again it will be balanced. At one point it will be balanced. You need to find that point. Make sure that your point of rotation is not changing. Slowly you rotate. Yes, now it is going on that side. So somewhere here it will be. Yes. Fine. Little bit adjustment. Okay. Balanced. This is my equilibrium position. This point it is balanced. Again, repeat the procedure. Measure the distance. So here first tabular column, serial number 2, second reading it is right. Weight in first column, weight in the weight hanger. What is the weight in the weight hanger? 100. Now you have added the second mass, 100. Distance, this distance. Unknown weight, unknown distance. Finished. Come to tabular column. Our session serial number 2, weight in the weight hanger. You added 100. So converting this one into kilogram, either into 100 or divide by what? 1000. Divide by 1000 so that you will get 0.1. 0.1. Distance of non-weight. So how to find the distance of non-weight? From the point of rotation to this point. So this point I can read it as 69.6. 69.6 minus 51.7. 51.7. For easiness only I am taking this calculator and all. So only for the 3 calculation you are not allowed to use this calculator, but for doing fast I am using this one. So answer is 17.9. This distance I am getting 17.9 centimeter. This one I can convert into meter, which is equal to 0.179 meter. Next column you can see distance of unknown weight. Now you are able to do, right? Distance of unknown weight. Which is unknown weight? This is unknown weight. Distance. This is distance. Already fixed. What is that one? 30 centimeter. Now we are not changing in this one. So 30 centimeter, which is equal to 0.3. Now calculation W2 into D1. What is W2? First column into second column. Right? First column into second column. Divide by 100. into 0.1, you will get the answer as 0.01 0.0179. So final answer W1 unknown weight is equal to, so the quantity which you have obtained just now, W2 into D2, 0.0179 divided by D2. Which D2? Sorry, here D2 irukalla sir. No, D2 will be same, but if you're doing the calculation over this side, this D2 you have to use, that is 0.3. So when you're doing this calculation, you will get your answer as 0.0596. 0.0596. Say slight difference is there, that is not a big matter because small, very small change only. We can find the average. Then the last round, three observations are given. Last round, add your, see now it's balanced. Last round, keep your 150 last mass. Adjust. Do the same procedure. Yes. See, students, I mean, if you're, in my class last year, some students were there, and even though they are very poor in that theory part, it was very difficult for them to understand, but they were very good in this, physics. So students, those are getting very high mark while doing this experiment. They are adjusting, but they couldn't find the equilibrium positions and all. So they were feeling so it is very difficult. But some students, average students, are doing this one, but very easily. So physics is a, but if you have some interest in this subject, it will be very easy. Ingava. Balance. கொஞ்சம் நேரம் கொஞ்சம் கூட. See, now it is balanced. Equilibrium, rotational equilibrium, fine. Again, continue. Mass 150, distance you can measure. This is fixed 30. Calculation. Yes, come to that third setup. Serial number 3, mass 150 into 10 to the power minus 3. Why? Because in kilogram, which is equal, if you are not doing this one also 150, if you are using also same answer you will get, but it should be in gram. Now, which is equal to 0.15. Distance you need to measure from here. So this is what, 63.5. This one 63.5. This is 51.7. Already we have fixed that one. So 63.5. 63.5 minus 51.7. 51.7, right? 51.7, which is equal to 11.8. 11.8 centimeter, which is equal to 0.118 meter. Right? Distance of unknown weight, I am not repeating, it is already fixed. Unknown weight, I didn't touch that unknown weight. So that distance 30.3. Multiply which quantity? W2 into D2. First column into second column, you need to multiply. First column divided by 100. 0.118 into 0.15. 0.0177. So I am dividing that one. W1 last W1 is equal to 0.0177 divided by 0.3, which is equal to, divided by 0.3, Jimbalaka 0.059. So the question is, which is your answer? 0.60, 0.596, 0.59. So answer is the mean value. You need to find the mean of this quantity. How to find the mean? Average of this all. Average 0.060 plus 0.0596 plus 0.059 all divided by 3, which is equal to 0.059. So just finding that average, 0.0596 plus 0.60 divided by 3, answer is 0.06 plus 0.0596 plus 0.059 divide by 3, 0.0595. So that is your final answer. I am writing the final answer over here. 0.0595 kilogram, which is equal in gram. How to convert kilogram to gram? Multiply by 1000, 1, 2, 3, which is equal to 59.5 gram. 59.5 gram. That is the final answer. So that is the first chapter, first experiment, determination of unknown weight. Now we found the weight of this one, which is equal to what? 50 gram. See, sir, gram, weight and mass, don't be confused. We are doing sole experiment in earth only, so that we can say as what mass is as weight, right? So that is about this experiment, unknown mass or unknown weight, which is equal to 59.5 gram. That is our first experiment. So thanks for watching this video. Again, we will come with our next theory session related to the theory second chapter. One more Ohm's law you will study. Second chapter, not fourth chapter. Your second experiment is coming on fourth chapter. By the time we will do that experiment in this lab. So far, be safe, be in home itself. All the best. Thanks for watching.